Hello all, welcome to this video tutorial on best first search in game trees. The workflow for this video tutorial would be like this. First of all, we are going to give you an introduction about best first search algorithm. After that, we would move on to a more technical aspect of best first search. Then we are going to discuss about the variants that come along best first search, that is the greedy best first search and the A star best first search. And after that, for a better understanding of the viewer, we are going to solve an example via best first search so that you could get a better grasp of the concept. And at the end, we are going to discuss the pros and cons of using a best first search algorithm or any other search algorithm. So without any delay, let's start. Let's begin with the first part, that is an introduction to search algorithms. So first of all, the question that comes to my mind is what is an AI? So AI for a commoner like me is nothing more than a machine that could replicate human actions without the slightest of differences. What would be a better example than the Deep Blue AI that defeated the legendary Gary Kasparov in chess in 1997? Or we could look at the AlphaGo AI which defeated Lee Sedol in 2016. So the thing is that the potential of AI to mimic and surpass human mental capabilities has exponentially increased over time. So the question popping in all of your minds would be that how does an AI manage to defeat an all-time chess champion? So let me tell you how this happens. It's a mere play of some search algorithms put in the right place with the right variables. But don't be fooled that an AI is just used for defeating some chess champions or anything. AI has a plethora of applications ranging from knowledge mining, robotics, autonomous driving, computational biology, software and hardware verification. In a way, many of the AI problems can be modeled as a search problem where the task is to reach the goal and from the initial stage via state transformation rules. So the search space is defined as a tree and the aim is to reach the goal from the initial state via the shortest path.
I will be talking about the classification of search methods. All search methods can be broadly classified into two categories. First one, uninformed or exhaustive methods, where the search is carried out without any additional information that is already provided in the problem statement. Some examples include breadth first search, depth first search, and others as well. Second one is informed or heuristic methods, where search is carried out by using additional information to determine the next step towards finding the solution. Best first search is an example of such algorithms. Informed search methods are most efficient, low in cost, high in performance as compared to the uninformed search methods. Now I am going to talk about breadth first search. If we consider searching as a form of transversal in graph, an uninformed search algorithm would blindly traverse to the next node in a given manner without considering the cost associated with that step. An informed search like best first search, on the other hand, would use an evaluation function to decide which among the various available nodes is the most promising or best before traversing to the node. The best first search uses the concept of priority queue and heuristic search to search the graph space. The BFS method uses two lists for tracking the transversal: an open list which keeps track of current immediate nodes available for transversal, and closed list that keeps track of nodes already transferred. Best first search algorithm works as following: create two empty lists, open and close. Second one, start from the initial node, say and put it in ordered open list. Repeat the next step until goal node is reached. If open list is empty, then exit the loop returning false. Select the first or top node and in the open list and move it to the closed list. Also capture the information in the parent node. If n is the goal node, then move to the node that closed list and exit the loop returning true. The solution can be found by backtracking the path. If n is not the goal node, expand node n to generate the immediate next nodes linked to the node n and all those to the open list. Reorder the nodes in the open list in ascending order according to an evaluation function fn. This algorithm will traverse the shortest path first in the queue. The time complexity of the algorithm is given by following expression. Variants of best first search. The two variants of best first search are greedy best first search and A star best first search. The greedy BFS algorithm selects the path which appears to be the best. It can be known as the combination of depth first search and breadth first search. Greedy BFS makes use of heuristic function and search and allow us to advantages of both algorithms. There are various ways to identify best node for transversal, and accordingly there are various flavors of BFS algorithm with different heuristic evaluation function. We will cover two most popular versions of algorithm in this presentation, namely greedy best first search and A star best first search. The only difference between greedy BFS and A star BFS is that in the evaluation function we can see the difference. For greedy BFS, the evaluation function is equal to Hn, while for A star evaluation function, the evaluation function will be the addition of Gn and Hn. Now I will be covering about uh, an example of best first search with the help of this game tree. Let's have a look at the graph on the right. Try to implement both greedy BFS and A star algorithm step by step using two lists, open and close.
So let's see the best first search example. So as you can see here, this is the graph. Here we will implement both greedy BFS and A star algorithm step by step using open and close list. Before that, let's know some terms. So here Gn is cost of path, Hn is estimated cost to goal, and Fn is combined heuristic, that is Gn plus Hn. So we will go parallelly with both greedy best first search and A star best first search, and we will go step by step. So first step will be start with start node S, which is here. So as you can see, it starts with node S, and here the path distance is 0. So in the open list, node will be the S and Hn will be the 10 as shown in this graph. So we will repeat these steps until the open list is empty or the goal node is removed to the closed list. After this, we have to move forward, that is move to the first node. As you can see in the right bottom corner in this graph, after S node there are three nodes A, B and C, and it will be included in the open list as Hn will be 9, 7 and 8 respectively for the greedy best first search. And for A star best first search, Hn will remain same, but there will be addition of path distance also, which will be 7, 2 and 3 respectively, as you can see in this example. So Fn will be the addition of both Gn and Hn. So therefore it will be 7 plus 9 16, 2 plus 7 9 and 3 plus 8 is equal to 11. And the parent node S will be the closed node. So after that we will reorder the list in an ascending order. So just we will reorder it, as you can see 7 8 9 just in ascending order, in both cases. Next step will be, we will move the first node from open list to the closed list. As you can see here, B is moved from open list to closed list. So as you can see, B, after B there will be the D and H and remaining A and C. So we will include all 4 nodes here in the open list, C, A, D and H, as you can see here. So which have values of Hn are 8, 9, 8, 6 respectively. So similar in A star best for search, we will only add the Gn value, which will the path distance. As you can see here, for node C it will be 3, for A it will be 7, for D it will be 6 and for H it will be 3, as you can see in this graph. So similar to the previous steps, we will do here, as we will add Gn and Hn and we will get the Fn. So after this, the Gaurav will continue.
So in this step, what we will doing is we just reorder the list in ascending order. So you can see here that Hn value is in ascending order. You can see that the Hn value of node H is 6 and for node C is 8 and for node D is also 8 and for node A is 9. So we just reordering the list in ascending order for both of the algorithms. So in the next step, what we will doing is we just move the first node in the open list to the closed list. You will see here that earlier H was is in open list, now it is in closed list. So from this, along with this, we just add the child node of H to the open list. You will see that G and F will be added here in the open list because uh, these nodes are the child node of the H. So the Hn value of G is 3 and the Hn value of F is 6. And in the A star best first search algorithm, along with the G and F value, we just added the path value of these nodes, which is 6 for F node and 5 for the Z node. For calculating the Fn value, we know that Fn value is the sum of path value and Hn value. So for Fn value of F node is 12, which is the sum of 6 plus 6 is 12, and for Fn value for G node is 8, which is sum of Gn plus Hn, which is 5 plus 3 is 8. Okay, so for in the next step, what we will doing is we just reordered the list in ascending order. So you will easily see here that Hn is in the ascending order. Like for G node, Hn value is 3, for F node, Hn value is 6. Similarly, you will easily see here that Hn is in ascending order. Okay, we just reordered the list for both of the algorithms. In the next step, what we will doing is we just move the first node in the open list to the closed list. You can see that earlier G is in the open list, now G is in the closed list, and we along with the moving of the first node, we are adding the child node of G to the open node. You can easily see here that the child node of G, which is E, will be added in the uh, open 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 list along with the Hn value, which is 0 for E. And in the A star best for search algorithm, along with the child node addition, we just add the path value of the E, which is 7 in this case. And for calculating the Fn value of E node, you can see that the Fn value is the sum of Gn plus Gn and Hn, which is 7 in this case. In the next step, you just reordered the list in the ascending order for both of the algorithms. You can easily see here the HN value is in ascending order, like for E is 0 and for F is 6. Similarly, you can see that the all of these value are in the ascending orders. Here, HN value is also in ascending order. Okay. Mm. Next step, you can, uh, sorry. In next step, you will see that we will move the first node in the open list to the closed list. Like here we will just reach our goal node, so we returning true as the goal node E is moved to the closed list. And for getting our optimal path, we just backtrack the closed list. You can see here that for backtracking, like E to Z and Z to H and H to B and B to S, we get our optimal path. Same thing is for the A star best for search algorithm. We will exit returning true as the goal node E is in the closed list. For backtracking, we just know our optimal path, which is same as that of the best first search in the first algorithm. Like you see that E to Z, Z to H, H to B, and B to S. This is our by backtracking, we see that this is our optimal path.
So, after critically analyzing the greedy BFS and the A-star algorithm, it turned out that both of them were equally efficient. But the A-star edges ahead and provides us with a more optimal path as compared to the greedy BFS. So, we drew the following conclusions: that although the greedy BFS and the A-star algorithm are both categorized as best first search algorithms, when we need to pick a favorite, we choose a A-star algorithm as it is a complete algorithm and provides us with an optimal path at the end. But there is a downside to this A-star algorithm, as it uses more memory as compared to the greedy BFS in providing us with the more optimal path. So coming on to the last part of the tutorial, that is discussing about the advantages and disadvantages of the best first search algorithm. The first advantage that comes to my mind is that we can easily switch between the BFS and the DFS, thus gaining the advantages of both searches in a single package. The second advantage is that it is more efficient when compared to the DFS. But as they say in real life, nothing is perfect. Same is the case with the machines, and the best first algorithm has a major flaw as it has a higher chance of getting stuck in a loop as compared to the DFS. So this brings us to the end of the tutorial. Hope everybody watching this tutorial had something to learn from it and could take away something from it.